if I can sell this item, so I will get the following profit. Okay, so the point is that what is the maximum profit I will have. So I want to find the average here. So if I gonna find the average, let's say its average is x, y, z and n, and when I will compare all those things, x comma y comma z comma n, and what I will found the more profitable, we will choose that. So these are those algorithms where chosen value are used in such a way that the probability of choosing each value is known and it can be controlled. So this algorithms little bit more we have to discuss in the knapsack. I hope it is included in the course. So this is known as the probabilistic algorithm, and second algorithm is heuristic algorithm. Well, heuristic algorithm is kind of a different algorithm where this kind of algorithms are used in the larger value, that is when we have to optimize the larger values, we use this kind of algorithm, and these kind of algorithms are not best. I'm not saying it best or worse. I just want to say that these are for the estimation of the large values, that how we can we can control the error. Here error cannot be controlled but may be estimated for the large it is. For example, I will give you an example, that way you will understand it better. Let's say I have an algorithm H1, and this is an heuristic algorithm. So we can, in this algorithm, we cannot control the error. We cannot control the error. If error is coming, so we cannot control that error. But what we can do is we can find out the t. What is t? The time, the estimation time. So we can find out the estimation time, that how much time this algorithm will took in order to complete it. So that kind of algorithm comes under the heuristic type of algorithm. There's a one more algorithm, that is approximate algorithm. So approximate algorithm is a kind of algorithm where answer is obtained that is precise as required in the decimal notation. In order to, in other words, it specifies the error we are willing to accept. For example, 2 figures accuracy is 8 figures, or 8 figures, or whatever is required. For example, let me give you an example of this kind of algorithms. So we are having approximate algorithm. So it is like it gonna help us in order to specify the error. For example, let's say I having a value, and then again a value. So if I'm gonna compare these two values, okay, so we are having one error. This, if we say this is x and this is y, and I'm saying that whether x and y are equal. So we say, well, the value of x is equal till here, but this point the both are not equal, right? So these kind of aspects, that when we have to write an algorithm, and the answer we have to obtain, it's a required decimal notation. So this is actually where we use this approximate kind of stuff, right? Then let's come on to the next topic of our algorithm, that is what is the steps in order to define, in order to the development process of any algorithm. So any algorithm can be developed with following 8 steps. The step number 1 is the problem description. As I told you, you have to reach from your home to mosque. So what are the steps that you have to took? So that comes under the problem description. And the second is the designing an algorithm, that you have to design that algorithm. Okay, that what are the steps you will take. Either you use the iterative form, you will use the recursive form, you will use the, let's say, any kind of form that you want in algorithm. So how you will design it. The third is you have to analyze it. After design phase is complete, you have to analyze the two things, that is the time and the space complexity. And then the fourth phase is develop an high level algorithm. So you have to develop the high level algorithm that you can implement in a code, which is also known as pseudocode. So you have to do that. Then checking the correctness of algorithm, and you have to check the correctness of that algorithm from every aspects, that where it is lagging, what is happening with it. So it should be perfect, because if you will give any algorithm that will take infinite amount of time, then your computer will be got hang, it will go to the loop state. So that cannot be happen. So you have to work on that, you have to check the correctness, that it should be okay at every aspect. Then the sixth point is it should be implementable. That means that we can implement it as a program. Who want to write an algorithm, but that algorithm will never get converted into a program? So that will be a blunder, because you are making an algorithm, but that algorithm is not going to convert into a program. Then it's that algorithm is kind of useless in that aspect. So it should be implementable, and we can wrote a program for it. And then 7 is actually the program testing. After we finally wrote a program, now our algorithm is converted from an algorithm to program. So now we should be able to know this thing, that our program is working fine, there is no such issue. The biggest issue that come is the programs got fall into the loop, and the loop is never ending loop, which is also known as the dead loop or infinite loop. So our processor will just print the values and it will never stop. So we have to test that at this programming aspect, that whether it is working fine or not. And then the eighth phase is the documentation phase. So what is documentation preparation? So every program comes with a document, that who is that author of that program, the date of that program, and all the the document related to privacy policy of that software. A lot of documents over there that comes packed with a software. You maybe have used any software of Adobe, or any software in general. You maybe use an application, an app in your phone. You can see that documentary of that software. So at the last phase, when everything complete, your algorithm is done completely, then you comes to this phase, which is known as the the documentation phase. Now we're gonna discuss about the another aspects of any algorithm, right? That is a representation of any algorithm or an algorithm. So how you can represent an algorithm? So represent an algorithm. I hope it's visible. Yeah, great. So we can normally represent any algorithm in a two way. The one is flowchart. I will tell you how it is, what it is. Okay. And then another one is the pseudocode. It's pronounced as pseudocode. So graphically depict the logical steps to carry out a task and shows how the task relates with each other. Okay, I will tell you in a simple words. See, so let's say you are having this, which is let's say a person whose name is X, and this is a person whose name is Y, right? And this person X want to meet Y, but only when the value of, let's say, G is equals to 1. Okay, only then he will has to meet Y, else he will meet to Z. So this is a kind of a step that I want to. So this is a decision checking. So whether G is equals to Y, if yes, so he will meet to Y, else he will meet to the Z. So that kind of condition, that when we are having some aspect that okay, he will going to meet to Y when the condition will be this, else he will going to meet the Z, that is Z. So that representation way comes under the flowchart representation. I hope it's clear, right? So this is a flowchart where pseudocode is different from flowchart. How? In pseudocode we actually write a code. For example, let me give you an example where I will write a code and you will going to understand it better. Okay, great. So let's say you are having a code, any code. We are having a while loop. Alhamdulillah. Excuse me. We are having a while loop where the value of n is declared is equal to 10, and we are saying that is value of n is greater or equal to 0, and the answer is yes. Why? Because 10 is greater than 0. So do one thing. What? Print, let's say hello. Okay, see, so what will happen? Hello will print for the 0th time, for the 1 time, till the 9th time, because 10 is neither greater nor equal to 10, I mean 0, sorry, 10 is actually greater to and equal to 0. Actually, I'm sorry, I wrote something wrong here. That is the conditioning, right? I have to correct it. So we are having basically a loop here. The value of n is, say, 10, but the value of this guy here is actually 20. Right? So now it's easy, right? So value of n is 10, so 10 is less than or equal to 20. The answer is yes. How then increment the value of n? Then n will becomes 11, 12. So when it becomes 20, so 20 is less than or equal to 20. The answer is yes. Why? Because it's equal, not lesser but equal. Then it's come 21. So do 21 is lesser or equal to 20? The answer is wrong. So what will happen is the loop will break down. So this kind of coding stuff, when we write in a kind of normal code, in a code that is understandable by human, so that kind of code, that is a rough code, it's not a program, it's not a flowchart also, it's not a program also, but it's in between that can be represented in English in a very simple way that anybody can understand. So that kind of thing is known as pseudocode. For example, while condition meets to 20, print something else, nothing, print nothing. Okay, print nothing, start from here. So these kind of thing which will going to contain code, like for example printf, or loops, while loop. So that kind of coding coding algorithms is known as pseudocode. So basically the difference between algorithms and the difference between pseudocode can be understood as an algorithm is basically the set of steps that is a pure human form steps. It's not be like we are having a lot of code in it, but the pseudocode will going to contain code that is understandable by as as a program, but it's not actually a program, but it's simple human understandable code that is used for represent something which is logical, right? So that is the difference between the pseudocode and the flowchart. Now we are moving to the next thing, which is knowing the conventions, that what convention is used for what, right? So there are normally we are having 5 conventions in a flowchart. So they are also known as flowchart symbols. Okay, so the one is this one. This is known as flow line. So used to connect symbols and indicate the flow of logic. It means that, for example, this is, let's say, start of a program. So we use flow line here in order to, let's say this is condition, we use flow line here. So what if this not? So all these flow lines are used in our flowchart in order to indicate the flow of logic, that how logic is flowing, what are the states, where to go, where not to go. So this is all done by our flow line. Then this is known as terminal. So terminal is used to tell about that, okay, so from where to start and where to stop. Okay, so when we start somewhere, so we use it here, and then whole we write the flowchart, and we come down when we end it, so we will write stop. So this terminal is used for pointing that from where the program is started and from where it will stop. And then another part is input and output. So this kind of stuff that you will be going to do in the input and output. So input and output, like for use for input and output operations such as reading and displaying the data. To read as displayed, is displayed or described inside. For example, input and output, it is used for the input and output operations like reading and displaying the data, and that kind of things is done from this representation. And for the processing purpose, we are going to use a rectangle. So rectangle is used for the processing. For example, used for arithmetic and data manipulation operations. The instructions are listed inside the symbol. So we will list here the arithmetic operations. For example, a plus b, a into b, like that. So this rectangle is used for the processing, and then we are having a diamond, this kind of thing. This is used for the decision taking. For example, a is greater than b, yes or no? If yes, if a is 10 and b is, let's say, 5, then yes. So if it is yes, then do this thing. If no, then do this thing. So all these kind of things are done with the help of diamond. So we represent decision making with the help of diamond, right? And then we are having flowchart types. There what are types of flowchart. I'm just covering the important things right now. Time is really less with the quiz will going to start then. Yeah. So what are the type of flowcharts? So normally the flowcharts are of 3 types. I will tell you what are those 3 types. The one is sequence flowchart. The another one is a decision flowchart. And the last one is looping flowchart. So we can also represent flowchart with various types, right? So how they work and what are they, right? The one which is the flowchart which is sequence, so it will having some sequence of steps. For example, it start from here, then it would be like, it will be reading some input, reading an input. For example, we have given some integer value, a is 10 and b as 20, b is also integer, so that kind of reading it's happening here. And then it will going to set the stamps, and then it will round the stamps, like it will process the data. So it will going to process it, and then after processing it will going to take the decision making that for example, this algorithm is having some decision making, a is greater than b or something like that. So that phase will be done here, and finally we will going to stop it. There was actually not a space below, so I wrote here stop it. So that kind of flow, see, it is on sequence. The first this, that, then this, then this, and then. So this kind of sequential flow is known as sequence flow chart. Okay. Now we are having the another flow chart, which is the decision flow chart. And the decision flow chart is basically kind of a flow chart where we will going to write the steps, but not in a sequence way, but we are free to write in any way. Like we can write in a rectangular form, or we can write in a, let's say, triangular form. We have to just wrote it in a way that it will going to it will going to represent our algorithm in a very efficient way. For example, I just want to write a program here. If a condition is true, I'm just writing like this. If condition is true, then process step 1. If condition is true, then process step number 1. Else, that means if the condition is not true. For that purpose, what you can do is we will go to step number 2 and then end if. What is the meaning of end if? It means that if is started here and ended here. That is the meaning of end if. So for that kind of thing, what we will do is we can say, hey, this is the point where we have started. So this arrow is indicating that, hey, we have started the flowchart, and here is condition. That's why I put this diamond. So what is the condition? As in the program mentioned, condition is that if it is true, then you will going to execute the process 1. I'm writing it P1, okay? And but if it is false, then you have to execute the process number 2. This is the way we're gonna select it, and then we will going to end our algorithm below. Okay, I hope it is simple, because all these things are like very introductory to algorithms. They are really very cool stuff in algorithm. For example, we are having dynamic programming, then we are having greedy algorithms. For example, Prim's algorithm. I don't know whether they will going to teach you all these things or not, but the algorithm is a very vast subject, and you have to learn a lot of things. The Corman book itself is so wide book. If you will read it thoroughly, then it will be really amazing, right? Okay, so now we are having the third kind of third kind of flowchart, that is a looping flowchart. So looping flowchart is basically simple. You are having a loop. For example, let me write a code here. Do, right, something you have to do. So we are having a do while loop, right? While the condition is true. Okay, so let's say I have a loop, do loop, that we having in Java programming language. Actually, we write like this. I think in C also we write something like this. So if let's say the value of a is a is equals to 5, right? If a is lesser than if a is actually lesser than or maybe the 2 units, the value of a is lesser than 10, right? What do you do? Print x, print hello, okay, and increment a. So what this code will do is, the initial value of a is 5, it will print something, that is hello. Then we will going to increment it, then the 5 becomes 6, 7, 8, and then when it becomes 9, so the condition checking will happen here, that if it is true 9 is lesser than 10, yes, so it will again print. But when it's become 10, so we know that 10 is not lesser than 10. So for that purpose, this will stop the algorithm, and our program will get executed, it will get returned. So that kind of looping is known as, that kind of flowchart representation is known as a looping flowchart. So how we will make it? Simple. We will start our flowchart, and we will put diamond here. Okay, this diamond will say the condition if it true. So if it is yes, it is true, then you have to execute this yes. And if it is wrong, so you have to process it first of all if it is correct, because I have given you this example. We have processing where 5 becomes 6, it go here 5, and then it becomes 6, and then it again come and it becomes 7, and then it again come. So that is why we have to put it here. We have to process it until and unless our loop is not getting false. When our loop get false, we will return, simply return, right? We will go to no, and then here we will going to return that okay, our loop is getting false now, and we are going to return our value. So this is about the 3 kinds of flowchart that we normally have. Okay, great. Now we will going to study next topic, which is pseudocode. Actually, we did it pseudocode in a different way, but according to our college, our university, we are going to know about them a little bit. So a pseudocode basically is a code that we write for any program in order to understand any kind of algorithm. So it is going to contain 5 ingredients. A pseudocode is going to contain 5 ingredients. The one is variable. I will explain each of them, don't worry. pseudocode is going to contain variables, right? It will going to contain the assignment, then the input and output, then the selection, and then a repetition. Example, let's say we are having some variables as x, y, z. Here x is equals to 10, y is equals to 20, and z is equal to 30. And the assignment will be like, for example, do x is equals to y, or it can be this condition, or it can be either greater or equal, or it will be equal or lesser. So these kind of conditions are come here in the second category. The third category is input and output. So first is we have declared this variable, and input and output will be the data that we are actually putting into it, and the data that we need after following conditions, right? So then the part of selection will come here. In the part of selection, we are going to select the value that came after the performing the operation of yes or no. When it is came as yes, so we will do the last stage, which is repetition. And till what value we will do the repetition? We will do till if it is not getting out, if it is not getting false, till that value we are going to do the repetition. So this is about the pseudocode, that how it going to represent things. So let's take an example. They have given us a problem. Problem is given a street number of a one-way street in New York City. So let's draw a diagram for it. So we are having New York City. So this is that street, and this they are saying it is one way. So what is one-way street? Right, one vehicle can move. Let's say it's a bus. One vehicle move in this direction, but there's a no another vehicle come from here. No another bus will come from here. So this is a one-way. So they're saying that giving a street number of a one-way street in New York City, decide the direction of street, either eastbound or westbound. So what is east and what is west? So this is north, okay, this is south, this is west, and this is east. If we can draw like this way, so this become west, this become east. So if we want to find out the direction, either the westbound or the eastbound, so we have to give it some way. For example, in a New York City, even number street as eastbound. For example, we are going to give this street as a eastbound as a number 1. Sorry, the even numbers, not 1, even number, the even number like 2, 4, that comes under the table of 2. And this one we are going to give the odd number like 2n plus 1, right? That is this is even, 2n is even, and plus 1 becomes odd. So if we give these kind of numbers, so then it will be easy for us to represent that which kind of street is where and what are the direction of it. So for that purpose we can write a basic program. I will write a program and then I will explain you about that program. So in order to know this bond of an algorithm, or specifically this algorithm, first we have to begin. Actually we are writing a pseudocode. This is okay, we will also have an example of pseudocode. So we started it. For when we start the algorithm, we write begin or start, anything we could start. Here we are writing begin, and when we are stopping the algorithm we will write end. So we are begin here, and we just put input, and then we put the street number, right? So what is street number? It's even or odd, that we will going to check. Okay, if street number mod 2 is equals to 0, right? If street number mod 2 is equals to 0, then print eastbound. I already tell you that eastbound is for even number and westbound is for odd numbers, right? You have to print the eastbound, else you have to print the westbound. Okay, So now you have to end the if here, and then you have to end the program here. You have to write the end. You begin here, and now you are ending here. So that kind of state is known as the pseudocode. We have write this problem of streets into the pseudocode, and yeah. So mode 2 will be actually whenever any number will give you the remainder is 0, so that number is nothing but even. Any number which giving you remainder not 0 is nothing but odd. So that's why when it's coming even, we are saying it's east bounded, and when it's coming odd, we are saying it's west bounded. They're very simple, nothing, no, it's not really difficult to understand. It's very simple, easy kind of thing. Now we are going to move to the next thing. So they have given the same problem of New York street into the form of flowchart, so that you can understand how you can write a flowchart. So we do it. Okay, so we start the flowchart, start it, and then here we are going to get street. So here we are going to get the input output. Here we will going to get the input actually. So what is the number is street, and then here we are going to do the decision making. Okay, so if it is the decision is yes, so it will going to display the eastbound, and if it is no, then it will going to display the westbound. If it is yes, that means it's even. If it's no, then it will be going, it means that it is odd, right? And finally we will going to terminate the algorithm after knowing that what is the state of our algorithm. So we will end the algorithm then. I hope till now the things are clear. If anything is not clear, then let me know, please. You can message me, I will text you again that okay, so this is what it is. Next thing is about the analyzing of algorithm. So problem has given, then we have to discuss that problem, then we have to output the grades. For example, in this case they have given some student case. So here they are saying that a problem is calculate and report the grade point average of a class. So you have to tell about the class, that there's a class where you have to take you have to tell the average grade point. So what is average grade point? For example, a class is consisting of 40 students. So some of them brings A, some of brings them B, and some of them C, and some of them brings D. These four grades they have, some of them all 40 have, some of them have this or this. So what is average grade of whole class? It may be A, it may be B, it may be C or D, any grade it could be. So that average of whole class is known as the average grade. So we got the problem, then we will do the discussion, that is the average grade equals the sum of all grades divided by the number of students. So sum of all the grades with respect to their quantity. So let's say 2 students got this, and 10 students got this, 8 students got this, and then 20 students got this, likewise. So the sum, their sum by averages the number of students is known as the average grade. So output, we have to output the average grade, and in input we have to input the grades of the student. So I'm writing it as student grades. Processing, it will going to process by counting the number of students, and then it will going to calculate the average. So this kind of problem will going to tell you about what are the grades of any student, right, in general. So the next slide they are saying that we have to represent this same thing with the help of a flowchart. So in order to represent with a flowchart, it will be a really long flowchart. Let me explain you that how and what it is. So when we start, we're going to start with a counter is 0. right? And then we will say a question that are there more data. So if the answer is no, so then we will going to set average to the sum and encounter, and if it is yes, then we will get a new next grade, and then we will increment the counter, and then likewise we will do it. So it is simple. Let me explain you. What will going to happen is we are having students, right, all of having some grade. Okay, so we are going to go to the students one by one, and we have to check that do the students are present in the class, there are more students. If yes, so the counter will increase by 1. Likewise, when the condition is fulfilled, I mean the condition gets over, so we will have the value of count here, that how many students are there, and we will also have their grades. What are their grades? A, B, the count of a grades and the count of the students, and then when we do the division of both of them, so we will get the average. In programming, in algorithms, we also use the term amortage for the purpose of getting the algorithm average. So average is also known as amortage in terms of programming. So next thing is that can we write the same problem into pseudocode, and the answer is yes. How? Simple. So let's say we name it, we actually name the algorithm. Here we are naming it as average. Okay, and then we are actually beginning it, so I write as begin, and then we are having counter, we are having sum. Initially we have done sum as 0, and after it we are having while loop, right? So while loop is that for the students, I will say that number of students present there, so we will use a while loop, and what we will do is we will input their grade, what they are getting grade, and then we are incrementing sum by sum plus grade. So here in this condition the grade are actually marks, so we add 0 plus grade. Let's say the first student marks is 30 and next is 40, so this loop will actually store the first person grade, and then when it moves to the second person grade, so it will consider its grade, store here, and then move and then move and then move until and unless the loop is not getting break. And with respect to that, this algorithm will also going to count the number of sum, right? So it will also going to calculate the number of students, the sum of number of students, as well as it will going to calculate their grades, right? So the loop will be like average sum by counter, right? And then you have to print this average, I am writing as avg, and then you have to end it. This is how you will going to represent this pseudocode, okay, for the student and grade problem. So one tip they have given you in this course is that by the way, I don't know why they make this course. It's like, I mean, it's not a real computer science, I'm sorry brother, but yeah, it's like okay, but you really need to work very hard with your programming skills, like, and you should know about how to represent like optimal merge, what are the various merging sorts different between them, like insertion sort, deletion sort, and what are the space and time complexity of each of them, and how you will represent in a code what is optimal merge sort, and what are all kind of trees, a binary search tree. So this is actually very basic and beginning. If you're gonna read it, you will get to know. It's not so deep that we can have a lot to be discussed, but let us complete it. It's not that difficult, we can do it together. Okay, so they have given you one trick about the flowchart. They told that flowcharts are time consuming. That's why software engineers or programmers will prefer writing pseudocodes. So this is a trick, really, this is a trick. So they told that the software engineers are basically, they used pseudocode instead of flowchart. Okay, so we will also going to use a lot of pseudocodes in our career instead of making flowcharts, because flowcharts are time consuming. Okay, so now the last slide of this, that is, there are many styles of pseudocodes. Yes, there are pseudocodes can be written in many ways. Some programmer use an outline form, some use a form that looks almost like a programming language. Outline form basically, it is combination. Outline form is basically their combination of two things, that is code and English. That kind of combination comes under the outline phase. And some programmer actually write a real program in a pseudocode. It really look like exactly like a program. So that kind of, some programmer use that kind of stuff. While the pseudocode in the case studies of the like text focus on a primary text to be performed by the program and leaves many of the root details to be completed during the coding process. What it means? Well, it means that the pseudo code in the case studies of this text focus on the primary task to perform by the program. For example, what kind of task a program will perform. Let's say we are having a program P, it will going to sort the numbers or swap the numbers. So that kind of task we will, we're gonna focus primarily when we are writing the pseudocode. Okay, so this is what we have to do, we have to focus on. So this was about this slide number 1. I hope the things are easy, I hope you understand the things. Thank you so much, dear.